Hello everyone, I'm Vincent. Many ads keep throwing around numbers like 1 million to 1 or 10 millions to 1. Do you know what those numbers mean? Actually, the answer lies on one key term, contrast ratio. It directly affects how clear the image appears, how transparent the colors look, and how strong the sense of depth is. So, what exactly is contrast ratio? What are static and dynamic contrast ratios, and what is the difference between them? In today's video, I'll explain everything very clearly. First, let's remember one basic formula. The contrast ratio equals maximum brightness divided by minimum brightness. The higher the number, the darker the blacks and the brighter the light, resulting in a more visible, striking image. There are two main concepts of contrast ratios for LCD displays with backlights: the static contrast ratio and the dynamic contrast ratio. The static one is a ratio that displays maximum and minimum brightness at exactly the same time, while the dynamic one is the brightness ratio at different times. Since the backlight's brightness can be adjusted, the same display's dynamic contrast ratio is greatly higher than its static one. However, only the static contrast ratio can reflect the actual display quality for the same picture, which is more valuable. LED displays are self-emissive. Their static and dynamic contrast ratios are the same. When LED displays show a pure black picture, the lamp beads can completely stop emitting. In terms of the brightness, the minimum value is close to 0. According to the formula, the contrast ratio can easily reach millions or even 10 of millions to 1, which is meaningless. To avoid the limitation of the darkroom test data, the industry has largely adopted the 10 lux ambient contrast ratio standard. This standard requires displays to be measured in an environment with the illuminance of 10 lux. Under these conditions, the images seen by human eyes include not only the light emitted by the display itself, but also the ambient light reflected by the screen surface. The core point of this standard lies on incorporating screen surface reflectance into the evaluation system. It not only tests the display's own light emitting quality, but also evaluates the encapsulation process ability to suppress the reflectance light. The lower the screen surface reflectance, the lower the minimum brightness, and consequently, the higher the contrast ratio. Actually, 10 lux of ambient light is still very dark. It is quite different from the actual environments where the LED displays are used. To better demonstration the contrast performance of LED displays in bright environments such as well-lit meeting room and outdoor advertising, Absen has always been deeply researching ambient contrast ratio. Ambient contrast ratio refers to the contrast under a specific ambient light level, taking into account both the light emitted by itself and the light reflected by its surface. It places great emphasis on the screen's anti-reflective capability. This metric directly addresses the common issue where displays show excellent darkroom specification but appear gray and wash out under ambient light. It is a truly meaningful display indicator that reflects the actual visual experience of end users. Absen has always been committed to researching human visual perception consistency, with the goal of bridging the gap between objective parameters and the subjective visual experience. The HTB panel level packaging technology we use not only ensures a high light transmittance, but also achieves extremely low surface reflectance. This greatly improves ambient contrast ratio performance. A great display must withstand the test of light. Absen constantly pursues innovations at the fundamental engineering level, ensuring that the image quality standards truly align with the authentic visual perception of human eyes.